Blocking task mutex is not a member of task. Hello, peoples. Add links. It works. I am kind of cleaned up a little bit the block task that I wrote yesterday. I think I got rid now of a blocking task or block task, or what was it called? Blocking is this. It's, something is blocking. I think it was lock blocking. Anyway, nothing exists anymore. No, seriously. Let's look for blocking. Yeah, no, that's a bit too much, isn't it? Why not just do a git diff and then see what it actually was? Too much. What crofrums? I'm cleaning up a little bit. What is this? Like log blocking, that's what I got rid of. So grab all the sources for log blockings. Here it's gone now. And this is the work that I did. Let's go to set for task, git status, git diff. So this is ripped log blocking completely from the AI stateful task mutex. And the dbus task also remove the log blocking from it. Instead, you now can pass a boolean to the constructor of a dbus log, and if that is set to true, then I'm using the new blocking task mutex to the blocking log. So it now happens at the moment you create this object rather than calling log blocking on it. Not log blocking gone. You see then how it is used. Instead of calling log blocking, I'm just passing now true to this dbus log thing. And again here, no more call to log blocking, but just passing true to the constructor of the thing. And again. Yeah, and then we had to add this to the linked list for this error testing. So I guess the correct commit message here is or something like that. I don't know. So yeah, git commit, git push. Oh, detach head. I don't like that. Why do we have a detach head? Did I make the same mistake with the last thing that I changed, which was a dbus task, I think. Git branch. Oh, this is on master. Nobody gets it. Get you. And then I made a few changes to block task. The destructor now unlocks new mutex if it is locked. And I added a license header. Yo. And a usage. So how to use the blocking task mutex. So there's calling unlock is an optional, because if you leave the scope of this thing here, then it will be destructed, and the destructor also unlocked. Okay, well, so git commit -a, and what did we do? Usage and license. Well, let's not mention the license. No, okay. And license header. And then now I can commit this, which is the work of several days. So now using the new block task. Oh, let's see where you have this more. Passing a shader index as a const reference, kind of silly. Oh, a lot more of those. Let's not do that. Yeah, so the main thing here is that I'm now having a cache for the shaders. So I guess that's going to be the commit message. Well, a pre-fill state. I don't think I need to keep that. But okay. Oh, it solved the fix me. The fix me is gone. Hello, A4. Oh, I did just some additional work on the block task thing. I removed all the log blocking from the code. Now using that new task. And then I fixed that fix me in what I did today, 2 days before that. You know, I needed to use I needed to use the log blocking for for IMQ. I mean, I never implemented it. But now it's a clean commit in that there's no code being committed that might crash under certain race conditions, because I just implemented it correctly now. Yeah, I'm just semi-looking for silliness. All right, didn't I want to change this back? Wait. Well, not this, but the call to this. Well, then it is already changed back. Yeah, that comment here. I changed this back, I think off stream. So first I was like, well, this is a bug, and then I changed it, and then later I changed my mind and changed it back. The trick here is that this function is returning a standard vector. And the lifetime of the returned vector is needed until the end of the scope in which it is called. because we use a pointer to the data of this vector. But what I'm doing here is it seems like I have a temporary, a local vector here, which is then returned. That's allocated here, returned here. And this line, it's calling set attachments, passes a reference to this vector, and then calls data on it. So it gets a pointer to the beginning of the an allocated array of the vector. And that pointer is stored in column blend state create info. And now we return, and then we use that in the scope of the caller. So I thought when I saw this, that cannot be correct, because data is a pointer to a vector that is destructed at the end of the scope here. And then that pointer would in the color blend state create info would be dangling, and then we still use it in the scope of the caller. However, I never crashed, so I thought, why did I not crash? And then I thought, well, that's probably by pure coincidence, because of copy elation. That is, a compiler is allowed, not required, to skip the call to a copy constructor or a move constructor if you have a construct like this. So we have here the return type, and then we allocate it the same type again here, and then we return that. Then it is allowed for the compiler to not allocate this, but simply use the vector that was, allocate a vector on the stack that is then known to the caller, and use that instead. So there is no copying here from this vector to that vector, or moving for that matter. But it's also not guaranteed. However, copy elation is not guaranteed, but if there is no copy elation, then there is moving. It would move this vector to the return value, to the returned vector. And then the question is, does that guarantee that the data pointer of the vector is not invalidated? And you have to search really, really hard in the standard to find that, and even then it's vague. It's like there is a page on cpp reference.com that kind of is the most clear, that says that I'll show you. Hope I'm not boring people with this kind of type. But on the other hand, it's you can also see it as a detective novel. It's exciting-ish. So you have here specialization, example. Wait, I thought it was under. Okay, that's not the right, just different page. Damn, what page was it? Yeah, it rolled off. I thought it was cpp-reference.com. Maybe you can look at my history. clear. Maybe on the constructor. Yeah, there it is. Sorry, it took a while, but I found it. So this remark here is then the most clear that you can find. It says that after container move construction, the overload 8 above, references, pointers and iterators other than the end iterator, they remain valid. But refer to elements that are now in this. In other words, if I call the data, which returns a pointer to the first element, or well, it's a contiguous array, so to the beginning of the array, basically, of that is represented by the vector, then that is a pointer, and that would stay valid if you move the vector, because it is a container. And then they said the current standard makes this guarantee via the blanket statement. Now, if you click on that, this is the statement. Oh, you cannot see that. Oh, you can just see it, I think. Unless otherwise specified, either explicitly or by defining a function in terms of other functions, invoking a container member function or passing a container as an argument to a library function shall not invalidate iterators to or change the values of objects within that container. Well, it's very hard to read. They talk only about iterators, but then you could add to that iterators of a vector are pointers. So if iterator is not invalidated, then also pointer is not invalidated. Nevertheless, it is super vague. And then there was somewhere else a discussion going on within the C++ committee that they want the data pointer to remain valid if a standard vector is being moved. And then they said this blanket statement is not very clear, so maybe we should make it more clear. And then they started to discuss that, and the last work that was done on that is from a whole year ago. So it's, yeah, not really clear. Nevertheless, I even changed my code back because I have the feeling that I want to rely on something obscure as this. So I'm now assuming that if I read data on this vector, that will equal the data pointer of the returned vector after we return from this function. But it did warrant a comment. And the comment, note, this call stalls pipeline caller blend attachment states .data, but that should remain valid upon returning from this function, since the caller either move constructs from the returned value or even copy elation applies. Anyway, it works with this compiler, so not important. Yeah, it's just some reformatting. Yeah, I'm no longer doing the destroy shader module handles at all, and this is something else, even though they share the end if. New asserts. Compiler is now initialized in initialize. I don't think this is really necessary though. Could revert this. Not even sure I use it. I do call initialize, I remember now, but why not do it from the constructor? Yeah. So we created a shader info cache, which is now being stored instead of the shader info. And that contains stateful task mutex and the handle to the compiled shader. So that then comprises a cache. Okay, so this has a range of 1. The range has a size of 1. And that's the vertex pipeline characteristic range. And then the other one has a size of 2, which is the fragment pipeline characteristic range. And that works. And then the problem was that if I make them both a range with a size larger than 1, then it crashes again, and I already figured out why. So this works now. And I say I make it, I make this one also 2. Then it stops working. Lots of validation errors. We crash. VK error. I don't know. Just score dump, I guess. This is the first validation error. I think this one. Vertex shader consumes input at location 2 but not provided. Well, it's probably because I have now 2 vertex shaders, which of course is not even possible. No, I only see 1. But I have 2 fragment shaders. Well, I'm gonna ignore then this comment. I'll just concentrate on the fact that we have 2 fragment shaders. So we're trying to create a pipeline here with 2 fragment shaders. Well, that's not possible. Pipelines have only 1 fragment shader. So how do we get a list with 3 stages here, being a vertex and 2 fragments here? Well, that is because I'm calling compile again. So I could make this assert probably earlier than this validation error. Might be more logical to do, well, at least nicer towards the user. So let's first turn this into an assert. Now it's too much. You gotta be kidding me. I cannot paste this in the chat. That's for Legion Gaming. I guess I should add the FAQ back to the description. Just it has been in there for so long that I thought everyone knows by now the answers to those questions. If you ask me, the real colors are 6-bit. So it's like 3 times 6-bit. That's 18-bit, not 24-bit. So is it really true color then? Not really. Well, 18-bit is enough, I guess, to get nice choice. But okay, apart from that, what was I doing? I was going to turn this into an assert. I really hate the stock market at the moment. I think let me click on a different tab so you get not distracted by this chat. And then I click on the stock market tab. Talking about it being distracted. Okay, so we have this, yeah. So somewhere I'm calling compile, which is in window.h. I'm going to change this into something else because compile it's not ready. Let's do add share. I think that sounds better. Okay. So when add shader is being called, that index is simply added to shaders that need compiling. Yeah, if you add an index that already exists, that's not good. Let me move this to the .cxx file. Preprocess 1 build shaders. It's using it. Preprocess shaders. Oh, it's a random place. Well, this is calling preprocess 1. I don't know. Let's put it there. So you can add the debug code here that asserts if you try to add something that already exists, thus avoiding having a duplicated shader. In fact, maybe I should not even look at the index, but I should just look at the stage that it goes into, which is even more debug code-ish. See if def cw debug. Yeah, I need information. The index is just an index. I need shader info, I think. Shader info object, which is defined in shader builder. And this is in pipeline, so okay. And I think I can get that with something like get shader info. Yep. Probably just takes the index. Well, variable name, shader info. This get shader info is element of the application, and it returns a reference. Okay, so this is a reference. Well, I just want to read it, so I can use a const reference here. That should work. And this must be called on the application instance. And then we have the shader info that belongs to the shader index. That should exist. What happens if it does not exist? Let me see. Get shader info. Oh, we just access something that's crash. I don't think it's possible to. Well, yeah, I'm not even going to add an assert here, because if you pass a shader index that you never retrieved from the right function, then you made one up. then whatever, then you may crash. So now we have a shader info, and that contains the stage. And I have a accessor for that even. Okay, so what I can do is I can run over all the, well, I want to run over all the elements. So I only have shader indexes. Well, okay. So I'm going to run over that shader index, all the shader indexes in this vector. Okay, and then if the shader index equals, or we try to add, oh, that's not working. Hey, that. Existing shader index then. Well, I would assert, right? I mean, yeah. But it is also not allowed. So I need to repeat this, unfortunately. Existing, and here also existing. Well, it looks like a whole lot, but the get shader, I mean, the instance is just inline return of an existing pointer to the application. And the get shader info is simply accessing a DQ. Well, it's logging a mutex, okay. That's not super fast. So if I was really concerned about that, but I'm not, then I could lock the mutex outside of this loop. But add shader is like not critical whatsoever. And then I'm going to assert that the stage is unequal as well. So the shader info stage must be unequal to the existing shader info stage. Yeah, I think the access was called stage. Yep. No, I should do it. So now we should assert here, because I'm just trying to add the same index again. Why am I calling my engine ask kill done? Well, because I want an engine. So now we crash here in this assert as predict. Okay, now the reason for that is that fillindex equals 0 is run twice. That is, this is being run twice for fillindex equals 0. If I look at that state machine or task, that is, if the fillindex equals 1, I add the shadow. So yeah, so if I run it the first time, I add it the first time, and I run it the second time with fillindex equals 0, then we add it the second time. And that's stupid, that it's not allowed. How to solve this? And the way I want to solve this is to simply never execute this again, because you already did. Instead, I should just remember what the result was after running it with fillindex 0, and then when I need it again, use the previous results. I'm so sleepy. There's something I have to do very quickly. Takes a few minutes, I'll be right back. almost back. You know, walking around anyway. Poo-poo. Cache. Yeah, it's a problem. How shall I solve this problem? I think I just I cannot with a good conscience copy those vectors. So currently I own a vector. My object, this object here, the characteristic owns a vector or more vectors. And it registers them with the flat create info object. And then it fills them. And then the flat create info can access them through that pointer. I mean, registration means we give the flat create info object a pointer to our vector. So then we fill that vector, and then the flat create info has access to it. But this is user code, so from the point of view of the user, it's easy to have a single vector. At least I thought that it was, and then just to update it, because if then it doesn't change, let's say you have a fill index 0, 1 and 2, then for 0 you can fill it, and then for 1 you realize that you don't want any change to that particular vector, so you just don't make any change. And then for at some point maybe fill index number 2 or 3 you want to make a change, you can only change a part of the vector even. So just updating a single vector, that seems to make most sense. But now I need to store those intermediate results. So maybe we have a vector that might or might not change between fill indexes 0, 1, 2, 3 and so on. And then later on I need the same contents again. I mean, was it changed? Was it not changed? Yeah, So if I let the user just update a single vector, then I will have to make a copy of the vector anyway afterwards, because I want to store the results. Or I can just say you get a copy for each, you get a vector for each fill index, and you just have to fill the vector again and again. And then I let the user make a copy if they think that it's the same anyway, so well, then make a copy. I guess I have to decide at the very least if I want those vectors to be owned by the user code or by my engine. To be honest, I've been thinking about this for a long time already, off stream. I mean, just thinking about it. And I cannot make a decision. I'm too much of a perfectionist. No, it's hot chocolate milk, Enzo. That is so good. I really don't like this because it's the whole idea of just updating vectors. It seems so cheap. You only have to make the changes that are, well, changing. You have only one place in memory, and then you make changes to it. Or you don't make any change when there is no change. Super cheap. And now suddenly I need to be able to reproduce that. So either I should have the user code do it all again, and then update it again, or I need to make full copies, which means a lot more memory and a lot of copying, even if nothing changed. Well, the way I registered with the flat create info is, yeah. We don't know anymore what belongs to which characteristic object. It makes it a kind of a difficult for the Vulkan engine, the pipeline factory in particular, to do stuff like resetting vectors, because it has a bunch of vectors, but it doesn't really know which belongs to which characteristic. So if I want to put any responsibility with the pipeline factory, and I probably will want it, then at the very least it should know which vectors belong to which characteristic range. Accelerator with water. Yeah. Yeah, A4 knows me. The true regular knows how I make my hot chocolate. I'm drinking hot chocolate, but I'm not doing nothing, right? I'm thinking really hard about this problem. Even though my mouse and cursor do not move. Post Bunny also knows. Of course, there's more than one regular, but A4 was the one that said border. Yeah, I like it this way. I should drink this from a mug like you were using, Post Bunny. Because the mugs that we use here in the Netherlands are small. It's empty like within I don't know, too fast. Why not drink half a liter of this? If I had a way larger mug, then I could just sip chocolate, hot chocolate for half an hour before it was gone, all gone. Yeah, in your country maybe. I don't think, like I said, a liter, to drink a liter of anything as soon as you drink any, something, a liter of coffee, for example, no, not healthy. Absolutely not healthy. Chocolate milk may be doable, but that would already probably be a lot of sugar. So how should I solve my vector problem? I'm leaning towards, I think, making copies. So the user has only a single vector, and they make their updates to that vector. And my Vulkan engine makes copies of it, so it can use it again. At the very least, then I need to know which vector belongs to which characteristic. Pipeline factory. Pipeline. Well, let's concentrate on this characteristic. It consists of two. The task consists of two states: initialize and fill. Initialize is executed only once. And that registers the push constant type. And it registers all the combined image samplers that are being used by the fragment shader. And this must be done during initialize. You're not allowed to do this elsewhere. And then fill is only saying which shaders it wants to fill. Use rather for the current pipeline. And add shader is a member of add shader stage, which is in the base class. And I skipped over it. And this characteristic range is derived from add fragment shader, which is derived from add shader stage. And add shader is then a member of that base class, virtual base class. And all it does is simply putting the index, which is a wrap around an integer, into this vector. And that vector is a member of also add shader stage. So it does absolute minimum work. However, the fact that we derived from add shader stage means that, well, we derived from add fragment shader, and that has a constructor, default constructor, and that is, and so it's using the default constructor of this base class. No, can't find it back. It isn't even defined, I think. Nope. The constructor is not doing much. At some point this must be called though. And I don't know from where. Let me have a check. That's being called from characteristic range of H. Oh, okay. When this is being called. It is being called from pipeline factory. As early as add characteristic. Gee, that's even before the pipeline factory runs. Yeah, okay. So back to the user code. The user code constructs the pipeline factory by calling add characteristic on it, and we're talking about this characteristic here, fragment pipeline characteristic. So at some point this is being called on the pipeline factory. And that then creates a characteristic. So this is the characteristic type. And it calls a new, creates a characteristic. And then it calls pipeline factory add characteristic with the pointer to the just created characteristic object. And that functions here then calls register with flat create info on that object that was just created. Which calls register all of these. And then if, say, we are not derived from add vertex shader, then it does nothing. Then we get, then we just call this one, which is then not overridden, so it doesn't do anything. But if we did derive from, let's say, add fragment shader, which we did, then it is overridden by that class. So then we do not call this one, which is, you know, doing nothing, but we call this one, which is also does nothing at the moment. Everyone happy? No. Okay, well, finally, however, we call add shader stage. And then that would be not this one, which has nothing, but the first one that we saw, this one. And this is add shader stage. And add shader stage is the vertical base class of the add fragments shader or whatever it was called, and therefore this is then what we will call, which then calls add to flat create info on the pipeline factory. Passing a vector that is owned by this object, the add shader stage object. And this vector is going to be filled with all our shader module handles. To be exact, what is in this is some flags, the stage that the thing belongs to, and a module handle, and maybe more. But in particular, of course, the handle to the compiled module and the stage that it has to go into, aka vertex or fragment shader. So this vector that we can only have two elements normally, one for the vertex shader and one for the fragment shader. And if we want to replace, say, the fragment shader by another fragment shader, then we would have to change this vector. And if we just want to keep the same vertex and fragment shader, then we can just leave it as it is. And you know, for the next fill index. But all we do here is register it with the flat create info. So what really happens is that we call add to flat create info with a pointer to this vector, which then calls flat create info add with the pointer, and that add is then overloaded by the type, basically by the T, the stuff that we store in that vector. And as you saw, that was a vector that stores pipeline shader stage create info. Stuffs. Now we have to add is a bit short to jump to. I might have to jump a million times, so I'm gonna jump to the flat create info object, and then we are looking for an add with that source this. So this add is going to be called then because this is the type of that vector, and we pass a pointer to it. That pointer is then being stored in this vector of vector pointers in the flat create info. And at this point we lose the information which characteristic that belongs to. So I guess that instead of storing a pointer to a vector, we have to store an object that contains a pointer to a vector plus a pointer to the characteristic. So we know which characteristic that thing belongs to. Yeah, I don't think we can remove from it. We will only add to it. And this list is really, oh, that's a vector, okay. But yeah, so the index that we stored it in that vector is returned. And that will never change, I guess. So we can access it again if you remember the index here. Not even sure we do anything with that. I'm not doing anything with it. Just calling add here and poof, the returned value is not used. Yeah, it's not annoyingly difficult to jump to the add. But okay, we call there again. Okay. So if I want to store all those vectors like right here in this object, I mean currently we store a single pointer, and the pointer points back to the characteristic object, and that actually has the standard vector, just one of them. I still cannot make a decision. Who is going to store my multiple vectors? The characteristic range knows how big the range is, so it kind of makes sense maybe that would let that create that many vectors. Yeah, could do that, I guess. Could do that. So here I have a list of all the characteristics. And that is a vector of intrusive pointers to characteristic range objects using a characteristic range index as the index. So this is the index that enumerates all the existing characteristic ranges, apparently. Or identifies them. That would be this I here. And we do set this fill index. On a given I. Using the range counters, which is a multi-loop, I guess. Yep. So it's a crucial moment that the range counter for a given I returns to 0. So if we call set fill index and this value is 0, that would be the beginning of the range. And then maybe we have to do something special. Kind of a reset. These we have to detect that, I think. Range counters I get value. I'm starting to wonder if I'm not calling the fill state for the same fill index directly after another. The only way I would not do that here is when this is not set. Running tasks, that's the only thing. Yeah, that's just it. Oh yeah, that set fill index is doing that work. So I'm calling set fill index, and that detects that the fill index didn't change. And if it didn't change, it returned false, and therefore we don't do this. And therefore we do not send a do fill signal again. It returns true if it changed. So that should work already. But then it's also a special case when you call do set fillindex with the value 0, because then you might start over. If I could implement a total reset when we call it with set fillindex 0, clear all the vectors, start over, then that would also work, I guess. I already avoid compiling shaders again, and the rest might not be that much work. So maybe that's good enough. I think I should add an assert to begin with, then for registering or adding to the flat create info. When a standard vector is added, that it must be empty. And then the first thing we do is, of course, fill index 0. So all the vectors are empty when fill index is 0, and then later on I can just reset all those vectors, clear them all before running fill index 0 again. But I'm still not happy. I don't know. Copying things seems to make more sense, I have to say. If we would copy things, then we get here. I mean, even this one. And certainly all these calls here. They then should return an old value, a previous value. Well, not really these calls, but whatever they're doing inside. So the flat create info, let's say get pipeline shader shades create infos. That calls merge on that list. And I really need to know then which characteristic belongs to maybe I should change this into an array. Currently it's an unspecified vector, and unspecified as in the index is unspecified. It just is it's a bunch of vector pointers, and I don't know which characteristic. But what if this is not a normal vector, but it's I can just use the characteristic index to get the right vector pointer. I like that more. Yeah. In order to do that, I need to pass the number of characteristics to the flat create info. Is that possible? What is this flat create info? Where is it stored? It's a member of the pipeline factory. So we create a pipeline factory, and then the flat create info is default constructed. And I am calling add characteristic on the pipeline factory. And every time that happens, I could do some call to the flat create info saying that, yeah, we have another characteristic. And then make all those vectors grow inside the flat create info. Seems like a good idea. I'm very sleepy. It's time to cook dinner, and I think I'll quit for now. I have something to think about. It is, I think, the right way to go. Yeah, so to summarize, every time I call add characteristic, I want to tell the flat create info to make more room for the next characteristic. And then everything that flat create info currently merges must then be a vector pointer specific for each characteristic, which may be null if that isn't added at all. So then this is no longer an arbitrary vector, it's a vector with a predetermined size, one element per characteristic, using the characteristic index. So here I'm doing a pushback, but that then is being changed into simply writing to it. Using a characteristic index, which then must be passed to the add. And we can do that if it is called from the characteristic, and I think it is. Which means that the characteristic itself must know what its index is. And it can know that because it is being returned by add characteristic. I'm just not storing it yet, I think. So I have here the window. I'm getting back a factory characteristic ID. Oh, that does contain the characteristic range index. On top of the factory index. So of course, yeah, the characteristic index is specific to the factory. And those IDs are stored here. That's user code. Not sure why I need that, but okay. Yeah, anyway, the add characteristic here is creating characteristic, and I said I want the characteristic to know what its characteristic index is, right? So now the pointer is being passed to add characteristic of the pipeline factory as an intrusive pointer, a non-const intrusive pointer. So set owner, register. Now here we have the characteristic index. And here we have the characteristic range. So I can just add a function and then copy this into the characteristic range object. Before or after moving, doesn't even matter. Before moving is easier, I guess. The bloody thing already has a characteristic range index. How did it get that then? Set. It's already done. Who is calling that? It is done in add characteristic. So I wanted to add code that is already there. Yeah, I wanted to add it here, but it is 3 lines up. 2 lines up. So the characteristic already knows what its index is. That's very good. Okay, I'm going to rest. Yeah, and then pick it up later. So I'm going to stop streaming, guys. I'll see you later.